Hello guys, my name is EJ and I am an astronomy student from Rizal Technological University in Mandaluyong City. Before I start with my presentation, I just want to ask you a quick question. Have you perhaps ever wondered if there are any other planets beyond our solar system? If you ever did, then the answer is yes, and that is what we call the exoplanets.
Exo, 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 exo.
Finding our first exoplanet was never easy. Many astronomers believe in the possible existence of the exoplanets but weren't able to easily confirm it. Well, not until radio astronomers Alexander Wolfsjan and Dale Frail confirmed the existence of not just one, but two exoplanets orbiting a pulsar back in 1992. Then in 1995, an exoplanet orbiting a sun-like star was discovered by Michael Mayer and Didier Queloz. According to NASA's website of exoplanet explorations, there are more than 4,000 confirmed exoplanets already, and a variety of methods are now being used to search for them.
Exo, 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 exo.
The presence of a planet near a star works like a game of tug-of-war. As we all know, the star's strong gravitational force causes the planet to orbit around this star. However, though the planet's gravitational force is small, it still has an effect to its host star which causes it to wobble in space. Spectroscopists can then measure Doppler shifts or periodic velocity shifts of the stellar spectrum caused by this orbiting planet. In this case, when the star wobbles and moves towards the direction of the observer, visible light waves bunch up and squish together and looks blue in color. Then when star moves away from the observer's direction, visible light waves stretch out and look more reddish. This method is called radio velocity or Doppler spectroscopy. This method can be used for main sequence stars of spectral types mid-F through M. Stars hotter and more massive than mid-F rotate faster, pulsate, are generally more active and have less spectral structure, thus making it more difficult to measure their Doppler shift. The minimum detectable planet mass increases as the square root of the planet's orbital size.
Exo, 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 exo.
The next method is astrometry. It is still based on the wobbling effect on the star caused by the orbiting planet. However, astrometry measures the periodic wobble that a planet induces in the position of its host star by observing the star's movements in reference to the nearby stars. So if the target star has moves in reference to these other stars, astronomers can analyze these movements for signs of exoplanets. The limitation to this method are the distance to the star and variations in the position of the photometric center due to star spots. The farthest planet from its star that can be detected is limited by the time needed to observe one orbital period.
Exo, 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 exo.
Then we have the transit method. The transit method works similar to a solar eclipse, where the sun's light is blocked when the moon passes directly in front of it. Therefore, when a planet passes directly in front of its host star and the observer, this causes the star to get dimmer as its light is blocked for a brief period of time. This small change is enough to clue astronomers into the presence of an exoplanet around this star. Stellar variability on the timescale of a transit limits the detectable size to about half that of Earth for a 1 astronomical unit. Orbits about one star mass or Mars-sized planets in Mercury-like orbits with 4 years of observing. Mercury-sized planets can even be detected in the habitable zone of K and M stars. Planets with orbital periods greater than 2 years are not readily detectable, since their chance of being properly aligned along the line of sight of the star becomes very small.
Exo, 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 exo.
Exoplanets are made of the same elements as the worlds in our solar system, and based on their composition and structures are just as diverse. Some known as gas giant or Neptune-like planets are large gaseous worlds. Other gas giants called Jupiter closely orbit their stars, causing the planet to have high surface temperatures. Another category of exoplanet consists of super-Earths, smaller than the gas giants but larger than of Earth. Super-Earths are terrestrial and made primarily of rocky or icy material. Then the final category includes Earth analogs. Much as their name implies, Earth analogs are similar to Earth in various ways, including size, composition, and distance to their home star. Since we're already talking about exoplanets, you might also be wondering if there are extrasolar moons or exomoons as well, which is by definition moons that orbit a planet outside our solar system, called an exoplanet. However, although more than 4,000 exoplanets has already been discovered by the space telescopes, only one exomoon has been described, and it's still unclear if it's actually a moon. Astronomer David Kipping and his graduate student Alex Tichy first reported the possible exomoon in October 2018. The pair watched as Kepler 1625b, a Jupiter-sized exoplanet, passed in front of its star. Two surprises came during the observation of the transit. First, the transit of the exoplanet was completed in 1.25 hours earlier than expected, which suggests that something was gravitationally tugging into it. Then, there was a dip in light shortly after the planet finished passing in front of the star, possibly indicating a satellite trailing behind the exoplanet. Exomoons are really hard to find. Kepler 1625b's sun-like star sits about 8,000 light-years away from Earth. That distance makes the star only a tiny pinpoint of light. But advanced technology has allowed scientists to detect when a planet crosses in front of its star. And for Kepler 1625b's alleged giant moon, detection is easier because of its size. But for any potentially Europa-sized exomoons, which would be only a quarter the size of Earth, the dip in light as it moves in front of a star may still be too small to decipher clearly with the current technology. This time, I will show you 10 of the top intriguing exoplanets according to NASA. First is Kepler 186f. Kepler 186f was the first rocky planet to be found within the habitable zone, the region around the host star where the temperature is right for liquid water. This planet is also very close in size to Earth. Even though we may not find out what's going on at the surface of this planet anytime soon, it is a strong reminder of why new technology are being developed that will enable scientists to get a closer look at distant worlds. Second is HD 2094-58b, nicknamed Osiris. The first planet to be seen in transit or crossing its star, and the first planet to have its light directly detected. The HD 2094-58b transit discovery showed that transit observations were feasible and opened up an entire new realm of exoplanet characterization. Third will be Kepler-11 system. This was the first compact solar system discovered by Kepler, and it revealed that a system can be tightly packed, with at least 5 planets within the orbit of Mercury and still be stable. It touched off a whole new look into planet formation ideas and suggested that multiple small planet systems like ours may be common. Fourth is Kepler-16b, a real-life Tatooine. This planet was Kepler's first discovery of a planet that orbits 2 stars, what is known as a circumbinary planet. The fifth one will be 51st Pegasi b. This giant planet, which is about half the mass of Jupiter and orbits its star every 4 days, was the first confirmed exoplanet around a sun-like star, a discovery that launched a whole new field of exploration. Sixth will be Corot 7b, the first super-Earth identified as a rocky exoplanet. This planet proved that worlds like the Earth were indeed possible, and that the search for potentially habitable worlds, rocky planets in the habitable zone, might be fruitful. The 7th planet on the list will be Kepler-22b, a planet in the habitable zone and a possible water world planet unlike any seen in our solar system. Then we have Kepler-10b. Kepler's first rocky planet discovery is a scorched, Earth-sized world that scientists believe may have a lava ocean on its surface. Ninth of the list will be Kepler-444 system. The oldest known planetary system has 5 terrestrial-sized planets, all in orbital resonance. This weird group showed that solar systems have formed and lived in our galaxy for nearly its entire existence. Then on the 10th of the list is 55th Cancri E. 55th Cancri E is a toasty world that rushes around its star every 18 hours. It orbits so closely, about 25 times closer than Mercury is to our Sun, that it is tidally locked with one face forever, blistered under the heat of the Sun. The planet is proposed to have a rocky core surrounded by a layer of water in a supercritical state where it is both liquid and gas, and then the whole planet is thought to be topped by a blanket of steam.
Exo, 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 exo.
살며시 맞춘 X는 kiss 동그랗게 하는 오는 hug 혹시 벌써 알고 있을까 하루하루 몰래 쓴 편지 그렇게 끄트막에 적었지 그래봤자 준 적 없지만